2.4 Solutions and Applications of Right Triangles. To solve a triangle means to find the measures of all of the angles and the sides of the triangle. If there's not enough information to use the Pythagorean theorem because you only have one side, then we'll need to use trig function definitions. If the right triangle is not drawn in a specific quadrant, we'll modify the 6 trig definitions, and we'll no longer write the trig definitions using x, y, or r. Instead, we're going to use the words opposite, adjacent, and hypotenuse. Remember SOHCAHTOA, or some old hippie caught another hippie tripping on acid? We're going to use those to help us solve a triangle. When we're solving triangles, it helps to label the different parts of the triangle that we have. Whenever we are labeling a triangle, whatever angle is A, the side that's opposite that angle would be labeled lowercase a. Whatever angle is capital B, the side opposite that angle would be lowercase b. And we always reserve angle C to be the right angle. And then, of course, the hypotenuse would be lowercase c. So we're going to solve a right triangle given that angle A is 34 degrees 30 minutes and side C is 24.7 inches. So if we're going to solve this triangle, that means that we need to find angle B, angle C, side B, and side A. All right. So to find these missing parts, if we were to sketch out this triangle, let's do it like this. Like I said, we understand that the right angle is C, so we can go ahead and fill that in. We know that that's 90 degrees. And then we can say that this is A, and this is B. So side C, that's 12.7. And then we need to find the other missing parts. We have angle A. We can find angle B by just subtracting 34 degrees 30 minutes from 90 degrees, because we know that all three have to add up to be 180 degrees. So since we have one right angle that's 90 degrees, we know that the other two have to add up to be 90 degrees. So if I just subtract 34 degrees 30 minutes from 90 degrees, that's going to give me angle B. So let me do that. All right, so if I took 90 degrees and subtracted 34 degrees 30 minutes, first of all, I need to have some minutes to subtract from. So instead of 90 degrees, I'm going to write it as 89 degrees 60 minutes. And I'm going to, 89 degrees and 60 minutes. 60 minutes is the same as another degree, so that's the same as 90 degrees. And I'm going to subtract 34 degrees, 30, oh, I wrote that as a degree, 30 minutes. Okay, so if I subtract 30 minutes from 60 minutes, that leaves me with 30 minutes. And if I subtract 34 degrees from 89 degrees, that's going to be 55 degrees. I did it again. Let's see. It's supposed to be a minute. Okay, so angle B is 55 degrees 30 minutes. Now, to find side A or B, always work with what you're given. Like, I wouldn't want to use angle B because, unless I had to, because this is something that I found. And if I make it a mistake and I use it to find the other missing parts, then of course everything's going to be wrong. So let's say that we're on angle A. And if I want to find side A, then I can use the trig function opposite over hypotenuse. So which trig function uses opposite and hypotenuse? It would be sine. So the sine of angle A, which is 34 degrees, 30 minutes, is equal to the opposite over the hypotenuse. So to solve for A, we would just cross multiply this. You could think of this as a proportion, and we're just going to cross multiply the 12 times sine of 34 degrees 30 minutes. You could even rewrite this instead of having to change this constantly or plug in 34 degrees 30 minutes. We know that 30 minutes is a half of a degree, so we could change this to 34.5 degrees. Okay, and then we're going to cross multiply this. So this is what we would put in our calculator. 12.7 times the sine of 34.5 degrees. And that's going to give us the measurement for, or the length of side A. Now, when you put this in your calculator, make sure that your calculator is in degree mode because we're dealing with degrees. And I get that it's 7.1933 and so on. They didn't specify what place to round to, but since the only decimal that we see is rounded to the tenths place, that's what I'm going to round my decimal to. So I get that side A is 7.2. And that would be inches. Okay, so I'm going to write that here, 7.2 inches. So now we just need to find B, which would be right here. Okay, so again, instead of switching over to angle A, let's stay on angle B. Let's stay on angle A since that's the one that was given to us. And now if we're going to use a trig function dealing with side B is adjacent to angle A. So now we're going to use a trig function that's adjacent and that deals with adjacent and hypotenuse. So what trig function deals with adjacent and hypotenuse? That would be cosine. Okay, so the cosine of 34.5 degrees is equal to the adjacent over the hypotenuse. So we're going to do the same thing and cross multiply that, and we would put this in our calculator, 12.7 cosine of 34.5 degrees, and that will give us side B. And we get 10.46, which would round to 10.5 inches. And so side B is 10.5 inches. And now, since we have all three angles and all three sides, we have solved this right triangle. Okay, in this next example, we're given two sides. We're not given an angle. So let's sketch out our our triangle. And like we said, C is always going to be our right angle. And so then they've given us side C, which is our hypotenuse, and that's 53.58 centimeters. I'm going to say that this is A, so side A would be over here, 29.43. Then this is B and side B. Okay, of course, all right, so we're looking for side B and then our angles A, B, and C. So C we know is 90 degrees. And now we just need to find these three missing parts. Okay, so if I were standing on angle A, if I were standing right here on angle A, the two parts that I have would be my opposite and my hypotenuse. So the trig function that deals with opposite and hypotenuse are sine. So I would say that the sine of A is the opposite, which is 29.43, over the hypotenuse, which is 53.58. Now I'm trying to find this angle. So in order to solve for the angle, the inverse operation of the trig function would be sine inverse. So sine inverse, we talked about this in the last lesson, is written like that, and it's on in your calculator. So we're just going to take the sine inverse of both sides, which would cancel out sine, and that leaves me with A is equal to sine inverse of 29.43 over 53.58. So all we do is plug that into the calculator. Remember, you have to hit the sine button twice to get to sine inverse, and then plug it into the calculator. And we get, here they're rounding to 2 decimal places, so I'm going to round this to 2 decimal places, and this is our angle measure, and I get 33.317, so that would be 33.32 degrees. Okay, so that is my angle A, 33.32 degrees. Now to find angle B, we could do it one of 2 ways. We could say that we're standing on angle B, and we could use these 2 sides to find angle B, or we can we know that these have to add up to be 180. So again, we can subtract this from 90 degrees to get our angle B, and that would be the easiest way to do that. So if I take 90 degrees and I subtract 33.32 from it, that will give me angle B. And I get 56.68 degrees. So the last part that we need to find in order to solve this triangle is side B. So we could be on either angle. Now that we've found our angles, both of these are found, so it doesn't matter which one we use. I'm going to jump back on angle A. So if I want to use angle A, B would be my adjacent side, and I could either use adjacent and opposite, which would be tangent, or I could use adjacent and hypotenuse, and that would be cosine. So it doesn't matter which one. I'm going to go with cosine. So if I do the cosine of A, which is 33.32 degrees, is equal to the adjacent over the hypotenuse, which is 53.58. Okay, so then I'm going to cross multiply that again, and so in my calculator I would put in 53.58 cosine of 33.32 equals B. All right, so let me put that in my calculator. And we get that B is 44.77 centimeters. All right, so that's 44. And now we have solved this triangle because we have all 3 sides and all 3 angles. So the next thing that we need to talk about are angles of elevation or depression. the angle of elevation from point X to point Y is the acute angle formed by the ray XY and the horizontal ray with endpoint at X. So what that means is if we have a horizontal line, the angle of elevation would be this angle that is created when we have another array coming off of that same angle. So if we rise from a horizontal, that's called an angle of elevation. You'll see the difference if we talk about the angle of depression. So an angle of depression is also from a horizontal, but this would be the angle going down. You can go either direction, but if we have a horizontal line and then the ray is beneath the line, that's called the angle of depression. If we have a horizontal, let me go back up. If we have a horizontal line and the line goes is above that horizontal line, then that's an angle of elevation. So we can apply this to solve word problems or real-world applications. And the way that we would do that is to first draw a sketch and label it with the given information, label the quantity to be found with a variable, and then we use the sketch to write an equation relating the given quantities to the variable. And then, of course, we solve the equation and check to see if our answer makes sense. So this first application says at point A, 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. Find the height of the flagpole. So if we sketch this out, let's say that this is point A, and it says that point A is 123 feet from the base of a flagpole. Okay, so if we go 123 feet, and here is our flagpole. I'm not very good at drawing straight lines. Let me try that one more time. Okay, so here's our little flag. And they want to know what the angle of elevation to the top of the flagpole is. All right, so if this is our horizontal line, and so the angle of elevation, remember, is if we have a horizontal line and the other side of the angle is above that horizontal, then that's an angle of elevation. So it says that the angle of elevation is 26 degrees 40 minutes. They want to know the height of the flagpole, okay? So we're going to say that right now the height of the flagpole is x, and we're going to solve for x. All right, so in order to do that, we have to use trig function, or a trig function. If this is our angle, this side would be opposite angle A, and this side would be adjacent to angle A. Of course, this would be the hypotenuse, so, the right angle, so this would be the hypotenuse. Okay, so we're not dealing with the hypotenuse, we're dealing only with adjacent and opposite sides. So which trig function deals with opposite and adjacent? Tangent. All right, so the tangent of angle A is equal to the opposite over the adjacent. All right, so we know that angle A is 26 degrees 40 minutes. So that's the tangent of 26 degrees 40 minutes. Now to solve this, again, we would cross multiply. So we're going to multiply this 123 times the tangent of 26 degrees 40 minutes. And remember, we can put that directly into our calculator, the 26 degrees 40 minutes, just by pressing the math button, or that's on the TI-36X Pro, or if you have the TI-30X IIS, you have the little button that has the degree, minute, and seconds on it. So you just put that into your calculator, 123 times the tangent of 26 degrees, 40 minutes. And we get 61, and it doesn't say what to round to. Since this is just 123, let's round to the nearest foot. Okay, so I get 61.77, so that would round to 62 feet. Would be the height of the flagpole to the nearest foot. All right, let's try one more. From the top of a 210-foot cliff, David observes a lighthouse that's 430 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse. Okay, so if we have a cliff, let's say that this is a cliff, and the cliff is 210 feet. There's a lighthouse offshore. Okay, my lighthouse doesn't look great. Let's try this one more time. Okay, here's our little lighthouse, and it's 430 feet offshore. We are to find the angle of depression from the top of the cliff to the base of the lighthouse. So since we're trying to find the angle of depression, our other side of our angle has to be below the horizontal. So we need to go straight or create a horizontal, even if it doesn't touch the top of the lighthouse. We have to have a horizontal line to go from. And the angle of depression would be this distance here, or this angle below that horizontal, okay? And we are looking to find that angle of depression. Now, it says that the lighthouse is 430 feet from the cliff. Okay, so 430, this is 430 feet. And we know that this is 210. So even though the lighthouse may not be 210 feet, if we create a rectangle, we could say that this is 210 feet. This angle and this angle would be the same. They would be congruent. So if we were to find this angle, it would be the same as this angle. So it doesn't matter which one we find. It's going to give us the angle. So since this is all up in the air and this is not definite, we could just say, okay, well, we know this is 210 feet, this is 430 feet. So if I find this angle, it's going to be the same as the angle of depression. All right, so if we're looking for this angle and we have these two parts, this would be the opposite side and this would be the adjacent side. So again, what trig function deals with opposite and adjacent? It would be tangent. So if I'm looking for the angle, the tangent of, we'll just say A, is equal to the opposite, which is 210, over the adjacent, which is 430. Now, anytime we're looking for an angle, just remember this. Anytime you're looking for an angle, you're always going to have to use that inverse function. The little -1 button. All right, so we're going to take the tangent inverse of both sides to get rid of the tangent on this side and find the angle on the other side. All right, so tangent inverse of this stuff here. So that cancels out, and it gives me A is equal to tangent inverse of 210 over 430. And so that I would just put directly into my calculator. Tangent inverse, remember, press the button twice, and I have 210 over 430, and I get 26. Again, it's not telling me what to round to, So it's 26.02, so I'll just say 26 degrees would be my angle. It's the angle of elevation here, but it would be the same as the angle of depression here.